Hello everyone, my name is Priya Gupta and I am a faculty at Career Avenues. So for today we'll start with one of the numericals from elimination, that is from the EPD section, that is environmental planning and design. So I'll present my screen. We'll start with the numerical. What we'll do is we'll read the question, we'll go through every entity in that particular question, okay, and then we'll move forward with it, okay. So I'll present my screen. All right. So starting with it, right. So this is a GATE 2016 question. The question states a lamp source of 3200 CD, which is candela, is mounted yeah, is mounted on wall at a height of 2 meters from the working plane. Okay, this is important. It subtends an angle of incidence of this with the center of the plane. Illumination at the center is what? In lux. Fine. So again, what we'll do is whenever we read a question, the first thing we should do is draw the diagram. Fine. And then we'll look into the different entities that we have marked in this particular question. Fine. So imagine this to be the room. Fine. What it states is the lamp source is mounted on a wall. So just imagine this is mounted here. Fine. On a wall at a height of 2 meters from the working plane. Now imagine this to be the working plane. Fine. It's mounted 2 meters from the working plane. It subtends an angle of incidence of 60 degrees. So we know that if this is the normal, this is the angle of incidence, this is the angle of reflection, this is the plane, then this becomes the angle of incidence, this becomes the angle of reflection. Fine. So what happens here is this is the angle of incidence. The normal will draw. This is 60 degrees. Fine. This is the lamp source. So with the center of the plane, fine. Illumination at the center. Yani they have asked that the illumination at this point, let this be maybe O. Illumination at point O is how much? So now with the concepts we'll start. Fine. This is 3200 candela. Now what is candela? With this very famous diagram that we might have gone through while going through the syllabus. So there's this diagram. If this is the plane, this might be the light source. Let it be the torch or something. Okay, I'll just mark it like this. So the power of this light source is called flux, and it's measured in lumen, LM. Okay. Then this light, beam light, falls on this particular plane. Fine. So the power of this beam is measured in candela. Basically, the intensity of the beam. Fine. Next, the light falling on this particular plane is measured in terms of illumination. Fine. And this is what? Nothing but lumens per area or per meter square. Now, the reflected light from this particular plane falling onto our eyes is known as luminance. luminance. And this is nothing but candela per meter squares. This meter squares is in terms of distance, okay? Distance square. And this is area. So what is the story behind all these concepts? Why are we writing this? Because you'll understand that in this particular question, the light source is given in terms of intensity. The answer is demanded in terms of illumination. So you should know what is the difference between all of these. Okay. Now, one more thing. Now we know that what is intensity, what is illumination, what is luminance, what is flux. Okay. The second part of this question talks about working plane. So why is this important? This talks about the height. Okay, the question might have said that the height of the room is maybe 3 meters. Okay, and the working plane is at a height of 0.6 meters. So from this, you would have calculated the distance of the mounted light source. That would have been necessary because whenever we move forward with the question, the height from the working plane to the mounted source is important. Okay, that would be necessary. So I'll just erase these. Now, so elimination, we are asked for the elimination, right? Now the third part of the concept is when we are asked to calculate the illumination, E, if the light source is falling perpendicular, okay? If the light source is falling perpendicular to the working plane, the formula would have been what? Lumen per meter square, okay? But it's falling in an angle, okay? If it's falling in an angle, what we do is we require the theta, this particular theta, okay, to what angle that light source is falling onto the working plane. So this formula becomes into cos theta, and this theta is nothing but the angle with the normal, okay? This angle. Never be confused with this angle, okay? This is the angle that we require for cos. So we'll start with the numerical, right? Okay. So in question, we have the intensity. How do you convert the intensity into lumens or flux? The formula is what? F equals 4 pi into I. I is the intensity. We have the intensity. We need flux. Lumens is what? Flux, right? So E equals 4 pi into 3200. This became lumen divided by meter square. What is meter square? Firstly, this is the area. Whenever light source falls, it subtends the light in form of a sphere, okay? Something of this sort. So this distance we need. What is this distance? Let this be S. So this is SO. We need this distance. Fine. And this is the angle, 60 degrees. So we can use the theory of trigonometry here. We can just write this. This is 2 meters, right? And this is the angle. This is 60 degrees. So what would be this? This would be 30. Fine. We can use any of the entity from the trigonometry and find out this distance, which is SO. In this particular question, what we'll do is we'll use sine theta, that is sine 30 degrees. You'll be able to find out the hypotenuse from here, H, which is nothing but the radius. Because when we find out the area of a sphere, what is it? 4 pi r square. R is what? SO here, 4 pi SO square. How will we find the SO? We'll find SO using trigonometry. So I'll write it here. Sine 30 degrees is what? Perpendicular by hypotenuse. So hypotenuse becomes 2 meters divided by sine 30 degrees. It's 4 meters. So hence our radius is 4 meters. So what would be the area? Here 4 pi SO is 4 meters square. Okay, I'll write this here. 4 pi into 4 square, meter square. This is done. Now we'll need cos of theta. What would be the theta? The angle with respect to the normal, which is 60 degrees. Done. So from here, we'll get this gets cancelled out. This would eventually become how much? 200 into cos of 60 degrees lumen per meter square. So this becomes 100 lumens per meter square, and lumens per meter square is nothing but lux. So this was the answer. Fine. So when you go through this question, when you went through this question, you must have undergone so many concepts, right? The first one was what? The first was about the different entities like intensity, flux, illumination, luminance. Second, working plane, right? Third, about the illumination at perpendicular distance, at an angle. Fine. So all these concepts we learned through one question. So again, when I say ki whenever you read a question, don't just solve it. Go through each entity, research about it. What is it? What is the difference between the entities given in that particular question? Why does it say ki 2 meters from the working plane? What's the importance of the working plane? When it says it subtends an angle of incidence of 60 degrees. What's the importance of angle of incidence? What do you consider when you consider cos theta? What is the theta that you consider? Okay? What is this SO? Fine, everything should be very clear. So I hope this was clear to everybody. So for more, you can reach me out. I'll be teaching at these special classes by Career Avenues, which is Numericals batch only. So that's all. Thank you.